All right, let's look at the law of cosines in vector form. All right, so let's say you have a triangle, random triangle, and I'm gonna take this vector to be u, and this vector to be v. All right, then let's look at the law of cosines. Remember that c squared is equal to a squared plus b squared minus 2 times a times b and cosine of the angle in between. So we have that, right? So instead of using a, b, c, we're going to use vector u and vector v, right? So we know that the a is the same thing as norm of or magnitude or norm of vector u. B is same thing as norm of vector v, right? And C, this vector right here. So a vector from, say, from here to that will be a vector. Let's see. So in order to get that arrow, we can go backward on vector v and forward on vector u, kind of take a detour to go from here to there. So that will be the same thing as say u, vector u, because we are going forward, minus vector v, minus because it's going backward on that. So c would be the same thing. Right, so we can rewrite this law of cosine we had before. We're going to convert it in vector form, right? So this is going to be, right, c is same thing as norm of u minus v squared, right? A is norm of u, vector u squared, right? B is norm of v, vector v squared, minus 2 times a is norm of vector u, b is norm of vector v, and a cosine of theta is I'm going to leave it as cosine of theta. Alright, then we're going to expand the left hand side. Right, remember that the norm square can be written as the dot product with itself. So we have a quantity vector u minus vector v dotted with itself. So vector u minus vector v. Right, then this is equal to the right hand side. So I'm going to just make a copy of this. So and control C, and I'm gonna just put it control V. Right, so I'm just gonna put it right there. Alright. Alright, so if you multiply this out, expand it out, okay, so using a distributive law, and so you have a vector u dotted with vector u, that's a norm of u squared, right? And then u dotted with v, so it's going to be negative v, so it's u dot v with a negative sign. Negative v times u is negative v dot vector u, right? Negative v times negative v is positive norm of v squared, right? So again, this is equal to, again, the same thing. So I'm going to just put it here, right? Then you can see that there are a bunch of things you can cancel out. So you have norm of u square on the left and the right, and norm of v square and here, right? So we have, right, u dot v and v dot u are the same thing. So you have a negative 2. I'm going to just write it as u dot v is equal to, right hand side is negative 2, norm of u times norm of vector v cosine of theta. Right? Then we can divide through by negative 2. Then we get this equation. Vector u dot with vector v is equal to norm of u times norm of vector v times cosine of the angle in between. Right? So this is basically the law of cosine in vector form. So I'll just so this is law of cosines in vector form. Right, this is very useful to prove the next theorem called theorem 1. It says this: if two vectors are perpendicular, if and only if their dot product is equal to 0. Right? Let's see if we can prove that. Right? So let's prove the this direction. Right? So if two vectors are perpendicular, right? Which means that the angle is 90 degrees. So cosine of theta is going to be cosine of 90 degree, which is equal to cosine of 90 degrees is actually 0, right? So you can see that from here, dot product is cosine of theta times anything, so it's going to be 0 anyway. So this is going to give you 0, right? Then so that will just tells you that dot product is going to be equal to 0, right? How about the other way around? So this is a proof, kind of an informal proof of this implication, right? How about the other direction, proof of this implication, right? Assume that u dot v is equal to 0, right? Which means that by law of cosines, that let's say norm of u is not equal to 0, norm of v is non-zero, so only thing needs to be 0 would be can be 0 is cosine of theta equal to 0. Right? The only angle between 0 and 180 that makes cosine equal to 0 would be theta is going to be 90. Right? Therefore, vector u is perpendicular to vector v. Right? So that will prove that. So that's theorem 1. So vectors are perpendicular if and only if their dot product is 0. All right? That's it. I hope that this was clear.